Welcome to Brain Vision.
Hello everyone, in this question we will learn about some basic concepts of the chemical reaction, right? So in the given question we have to determine the fuel air ratio, right? We have the percentage by mass values of carbon, hydrogen, oxygen, nitrogen, sulfur and ash, right? So to solve this question, first of all we will determine the mole fractions of the coal components with the help of their masses and the molar masses. So the mole number of carbon would be equal to 79.61 as given in the question, divided by the molar mass of carbon, that is 12. So this will give 6.6342 kilomole. Similarly, we'll find the mole fraction of the other coal components. So for hydrogen, this value comes out to be 2.33 kilomole. For oxygen, that would be equal to 0.1488. For nitrogen, this is equals to 0.0654, and for sulfur, this is equals to 0.0163. Now we can write the general form of the reaction, that is 6.6342 carbon plus 2.33H2, right? So with the help of these small fractions, we can write the general form of the reaction. And this will give the product as BCO2 plus CH2O, right? Now the balancing of carbon, hydrogen and sulfur elements will give us the values of the coefficient. So B equals to 6.6342, C equals to 2.33 and D equals to 0.0163. To determine the coefficients A and E, a balance of both sides is performed, right? And that will give the value of coefficient A is 7.6667 and E is 11.52. With the help of these, we can write the final form of the reaction, and then we can easily determine the air fuel ratio, sorry, fuel to air ratio, with the help of the mole numbers of components of the coal and of the air. So the fuel air ratio would be equal to the mass of carbon, that is 12 multiplied by 6.6342 plus 2.33 multiplied by 2 divided by the mass of nitrogen, that is 11.5 multiplied by 32. This is the oxygen, and for nitrogen that would be 43.24 multiplied by 28. So this will give the fuel air ratio as 0.0579 kg fuel per unit kg of air, right?